Now at this point, you should understand that you can solve a system of equations by finding the point of intersection between two graphs. But there's also other ways of solving a system of equations using algebraic methods, meaning we don't need to graph anything. And in this section, we're going to go over two of those ways. One of them is called the substitution method, and the other one's called the elimination method. Both of those are algebraic techniques to solve systems. Now I'm going to start by going over the substitution method. In this method, we're going to solve one of the two equations for either x or y, and then substitute the result into the other equation. This will eliminate one of the variables and allow us to solve for that variable. Now let's take a look at this example. Now the first thing we're looking for is we want to try to solve for either x or y in one of the two equations. And so we want to pick the term that's easiest to solve for. And usually that's going to be a term that doesn't have any coefficient in front of it other than a 1 or a negative 1. For example, if we look at this first term right here, 3x, that's got a coefficient 3, so I'm not going to pick that one. This one here has a coefficient of 2. I'm not going to pick that one. This one here has a coefficient of 5, so I won't pick that one. This is the key one here. Notice the coefficient in front of the y is just a 1. Actually, it's a negative 1 because of the negative sign would apply to it. And that's going to be the easiest one to solve for without having to create a lot of fractions in the answer. So we're going to solve that for y. So if we take that equation, 3x minus y equals 10, and we want to solve for y, so we'll subtract 3x from both sides, and that gives us negative y equals negative 3x plus 10. And then the coefficient is really negative 1 here, so we divide everything by negative 1, and that would give us y equals 3x minus 10. So we've solved this equation for y. Now remember, we don't always have to solve for y. We can solve for x if it happens to be easier in a different problem. We can pick either x or y and solve for that variable in either of the two equations. Now once we get that done, we can take this 3x minus 10 right here, and since y equals 3x minus 10, we can replace the y in this other equation with 3x minus 10. And when we do that, we have to enclose it in a set of parentheses. So we would get 2x plus 5, and we're going to substitute in where that y is, 3x minus 10. That's why it's called the substitution method. And then we'll distribute the parentheses, so 2x plus 15x minus 50 equals negative 16. And then we'll go ahead and solve that for x. So we combine our like terms together, so 17x minus 50 equals negative 16, and then add 50 to both sides, and that would give us 17x equals 34, and then when we divide by 17, we end up with x equals 2. Now we still need to find y, but we can take this x equals 2 and substitute it right over here into this equation, plug it in for x, and then we can find out what y would be. So y would be 3 times 2 minus 10. So y would be 6 minus 10, which comes out to be negative 4. So x is 2 and y is negative 4. We can put those two pieces of information together into one ordered pair, where the x-coordinate would be 2 and the y-coordinate would be negative 4. And that would be a way of writing that answer. Now, do you remember the two special cases we talked about where you had two parallel lines and so there's no solution, so we answered inconsistent to something like that? And the other one is where we have the same line twice, so they fell right on top of each other. In that case, we say a system is dependent. So I want to show you how that would show up when you're using the substitution method. So in this example, notice that in the first equation, it's already solved for y, so that work's already done for us. Y already equals 5x minus 4. So we can take this 5x minus 4 and substitute it in for y right there in the second equation. And again, that's always got to go inside parentheses. So we'd have 10x minus 2 times parentheses 5x minus 4 equals 12. And of course we know we have to distribute this out. Now be careful, that negative goes with the 2 there, so you have to multiply by negative 2 both times. So that will give you 10x minus 10x plus 8 equals 12. And when you combine your like terms, 10x minus 10x is 0, so they cancel out, and you just end up with 8 equals 12. Now notice this is a little strange. The variable dropped out completely, and we end up with a false statement. Now when this happens, it means the system is inconsistent because it's never going to be true, so there's no solution. Now sometimes a similar thing would happen. The variable still drops out completely, but you'll end up with a true statement. Now this would mean that it's true for any value of x, and therefore we would answer dependent. So these special cases will show up when the variable drops out completely. Okay, notice that happens in this situation. And depending on whether we end up with a false statement or a true statement, we would answer either inconsistent or dependent. Now in our case, we end up with a false statement because 8 equals 12 is false. And since that's false, our answer would be inconsistent. Okay, now let's go over the elimination method. Now, in the elimination method, we're going to multiply by constants to get opposites in either the x or y terms, and then we'll add the equations together. So we want to try to arrange it so either the x terms here or the y terms are opposites. Now by opposites I mean they're the same, but one's positive and one's negative. So the opposite of 3x would be negative 3x, so I don't have opposites here. And the opposite of negative 4y would be a positive 4y, so I don't have opposites there. So since I don't have any opposites in either the x or the y's, I need to multiply one or sometimes both of the equations by a constant so that we'll get opposites. Now in this case, I'm going to try to get the y's to be opposites. So I'm going to focus on the y variable here. And I've got a negative 4y in the top, so I'd like a positive 4y in the bottom. I've got a negative 1y, so I'm going to multiply the bottom equation through by a negative 4. So I'm going to multiply both sides by negative 4. Now sometimes I just show that this way, that I'm going to multiply everything by negative 4. That means all three terms. So you'd start with 4x times negative 4, so that'd be negative 16x. And then you do negative y times negative 4. Now that's a negative times a negative, so that's plus 4y, which is what I was trying to get. And then the equals, and then I have 11 times negative 4, which would be negative 44. Now the top equation, I don't need to change at all in this example, so we'll just copy that down. So 3x minus 4y equals 18. And now that I've got the opposites that I wanted right here, negative 4y and positive 4y, it's time to add the equations together. So I usually draw a line and then just add vertically. So a 3x minus 16x would be a negative 13x. And then a negative 4y plus 4y add up to 0, so they cancel out. You could put a 0 there, but I just usually leave it blank. And then the equal sign carries straight down. And then we have 18 minus 44, which equals negative 26. And then we just divide both sides by negative 13 because we're trying to solve for x. And so x equals 2. Now we still need to find y, and to do that we'll take the answer we got for x, which is 2, and we can substitute it into either one of the two original equations where the x is. It doesn't matter which one you use. So I think I'll just use the bottom equation. So I've got 4x, so that'd be 4 times 2 minus y equals 11. So 8 minus y equals 11. Subtract 8 from both sides. So negative y equals 3. And then that's really negative 1y. So divide both sides by negative 1. And y would equal negative 3. And again, we'd want to put these two things together to create a final answer, which would be an ordered pair. Of course, the x-coordinate comes first, so that would be 2, and then the y-coordinate second, negative 3. And this would be your solution. Okay, this is a new example. Now, I forgot to mention this before, but when you're using the elimination method, it's really important that everything is lined up straight. In other words, the x's have to be vertically lined up, the y's have to be lined up, the equal signs have to be lined up, and the constant terms lined up. So if it's not already in that form, you need to rearrange the terms by adding or subtracting from both sides to put it in that form first before you can use this method. Now, again, we're looking for opposites in either the x terms or the y terms. The opposite of 6x would be negative 6x, so obviously there's not opposites there. The opposite of positive 5y would be negative 5y, so I don't have opposites there either. Now, to get opposites in this case, it's going to be necessary to multiply both equations by two different numbers. And to figure out how to do that, think in terms of counting by the numbers. For example, let's say I wanted to try to get the x's to be opposites. Now, if I count by 6's, I'd have 6, 12, 18, 24, etc., right? And if I count by 9's, I'd have 9, 18. Well, notice I came across 18 when I counted by 6's and also when I counted by 9's. So I'd be trying to get 18x and negative 18x as my opposite numbers. So that means I'd have to multiply the top equation by 3. That would turn the 6x into an 18x, and the bottom equation by negative 2. And that would turn the 9x into a negative 18x, and then I'd have my opposites. So let's go through and do that. So 6x times 3 is 18x. And then 5y times 3 is plus 15y. And then equals, and then 13 times 3 is 39. And then for the second one, we're multiplying everything by negative 2. So 9x times negative 2 is negative 18x. There's the opposites I was trying to create. 4y times negative 2 is minus 8y. And then 2 times negative 2 is negative 4. And again, now that we have these opposites, 18x and negative 18x, we know it's time to add the equations together. And when we do that, the 18x and the negative 18x add up to 0. So we can leave that blank. And then we have positive 15y minus 8y, so that would be 7y. And then bring the equals down. And then 39 minus 4 would be 35. And then if we divide both sides by 7, 35 divided by 7 will be 5, so y equals 5. Again, now that we have that, we'll substitute that answer into either one of the two original equations. Doesn't matter which one. I'll take the bottom one. So 9x plus 4 times 5 equals 2. 4 times 5 is 20, so 9x plus 20 equals 2. Subtract 20 from both sides. So 9x equals negative 18. and divide by 9. So x equals -2. Again, we can combine those two answers into one ordered pair, and the ordered pair would be -2, 5, which would be the solution to this system. Now, I'm not going to completely do this example all the way to the end, but I'm going to just talk about how to handle these fractions. Now, if we have a problem that has a lot of fractions in it like this, remember we talked about before that we could get a common denominator. Now, I'm going to put this -1/1, so that looks like a fraction, and the same with that -8. And if we get a common denominator in all the terms, so 2, 3, and 1, the common denominator would be 6. That means I'd have to multiply the top and the bottom of this first fraction by 3, which would give me a 3/6. So I would end up with -3/6 x minus, and then for the second term we'd have to multiply the top and the bottom by 2. So 2/6 y, and then we multiply the top and the bottom of this last one by 6, so it'd be -6/6. And once we've done that, remember we can multiply both sides of the equation now by 6, which makes all of these 6's drop out and just leaves us with -3x minus 2y equals -6. So we'll work with that one instead of the original one. Now I could do the same thing with this other equation. Again, the common denominator between 2, 3, and 1 would be 6. So we'll multiply the top and the bottom by 3 in that first case, which would give us -9/6x. And then we'll multiply top and bottom by 2, so 4/6y. And then we'll multiply top and bottom by 6, so -48/6. And again, once I have that common denominator, I could multiply both sides by 6. That's going to make that drop out, and it would give me -9x plus 4y equals -48. Now, I could work with this new system, which doesn't have any fractions in it, which would be a lot easier going forward. Now, I'm going to let you finish this one by yourself and see if you can come up with the answer. I'll give you what the answer should come up to be so you can check it. You should end up with x equals 4 and y equals -3 as your final answer. Now remember those two special cases, inconsistent and dependent systems? Let's go over how that shows up when you're using the elimination method. It's very similar to before. The variable completely drops out, and depending on whether it's a false statement or a true statement, you would either answer inconsistent or dependent. So let's go ahead and see if we can get opposites. Now, we could get opposites in the x terms if we multiplied the top equation by 4, because that would turn the 2x into a positive 8x, which would be the opposite of negative 8x. So that's what I'm going to do. I'm going to multiply by 4 in the top equation, and that would give us 8x minus 4y equals -16. And then the bottom equation we don't have to change at all, so -8x plus 4y equals 16. Now notice what happens when we go and add these together. The 8x and the -8x add up to 0, which we expected because we actually created those opposites. But also the -4y and the positive 4y add up to 0. So we just end up with a 0 on the left side of our equation. And then -16 plus 16 also adds up to 0. So again, the variable completely drops out. So the question remains, is this a true statement or a false statement? Now obviously 0 equals 0 is a true statement. And whenever we get a true statement, you remember from before, we would say the system is dependent. So that would be our answer here. Now, sometimes you might end up with a false statement, like 0 equals 8. If that's the case, you would answer inconsistent. But in either case, the variable would drop completely out, and that's how you'll know you'll have one of these two special cases. Now, the last thing I'd like to go over today is how to solve an equation in one variable by graphing. And the way we can do that is we can view an equation as a system of equations. And by finding a point of intersection, we can actually solve an equation. For example, consider this equation, and we are trying to solve for x. Now, you could use the method I showed you before, where you get a common denominator between all these, but that would be difficult to do here, and I would rather not have to do that if I could avoid it. And there is another way of solving this equation using our graphing calculator, and the way to do that is to take each side of the equation and we'll put the left side of the equation in under y1 in our calculator. So we could enter that in. And remember, put the slope 42 over 97 inside parentheses. And then take the right side of the equation and enter that into y2. And then we'll graph both those lines together. And they should intersect each other. And we'll find that point of intersection. Okay, so we'll find the point of intersection. And we can do that using that intersect command on our graphing calculator. And then once we find that point of intersection, we're going to take the x-coordinate of that point, and that would be the solution. So it's important to realize the solution ends up just being the x-coordinate. We'll find that in just a minute. I'm just going to leave it blank right now. But for now, I just want to make the point that when you express your answer to this kind of a problem, it's just an x value answer that you're finding. The y value actually is telling you what both sides of this equation would come out to be if you had substituted that x in. Okay, so you see here on my calculator, I've put the left-hand side of the equation into y1, and I put the right-hand side of the equation into y2. And I want to graph these together. So I'll do a zoom standard, which is just your basic zoom. So hit zoom and then 6, and you see it would graph the two lines. And I'm interested in finding this point of intersection. And so we'll do second and then trace, and then we want to choose option 5, intersect. And then for first curve we just hit enter, and then second curve just hit enter again. And then for the guess, we move our cursor back so it's pretty close to where they intersect, and then hit enter one last time. And the calculator will display the solution. And as you can see, the solution for x, if we round that off to the nearest hundredth, it would be negative 4.38. So I'll write that down as the answer. Let's see. So negative 4.38. And remember, it's just the x, that's your solution. Now if I were to check this solution by substituting negative 4.38 into both sides of the equation where the x is, I should find that both sides of the equation come out to equal about negative 1.22, which is actually the y value.